Hello Medicose, welcome to the channel. Today we are going to talk about the body's temperature regulation mechanism. Ever wonder how your body stays warm in the cold or cools down on a hot day? In this video we'll explain how your body regulates temperature. From shivering and sweating to the role of the hypothalamus, you'll learn how your body manages heat gain and loss. By the end you'll understand how your body stays balanced in extreme temperatures and why this system is vital. We need a specific temperature range for our cells to work efficiently. Enzymes in our cells are sensitive to temperature changes. They need the right temperature for essential chemical reactions. If our temperature strays too far, these reactions can slow down or stop, risking our health. We need a temperature around 98.6 degrees Fahrenheit or 37 degrees Celsius for everything to run smoothly. This balance is called thermoregulation. It's how our bodies maintain a stable internal temperature despite external changes. This process is essential for our survival and well-being. Hey everyone, if you like this video, we create videos covering every subject and every topic related to medicine. So, make sure to subscribe and hit the notification bell to stay updated with our latest videos. Let's examine how the body generates heat in response to cold. When exposed to cold, the body activates mechanisms to increase heat production and maintain a stable temperature. The thyroid hormone increases the metabolic rate by stimulating Na+ and potassium ATPase activity, leading to higher energy consumption and heat production. The sympathetic nervous system activates B receptors in brown fat, increasing the metabolic rate and producing heat. Shivering is the body's most powerful heat generation mechanism. Cold activates the posterior hypothalamus, triggering rhythmic contractions of skeletal muscles, producing heat. Our bodies have a secret weapon: brown fat. Unlike white fat, which stores energy, brown fat is specialized for heat production. When activated, brown fat cells burn calories rapidly, generating significant heat. It's like having a tiny fireplace within our bodies, ready to roar to life when needed. Deep within our necks lies a small, butterfly-shaped gland called the thyroid. This gland plays a big role in regulating our metabolism, crucial for heat production. The thyroid produces hormones that travel through the bloodstream, instructing different parts of the body. Two key thyroid hormones, thyroxine, T4, and triiodothyronine, T3, are essential for maintaining our internal temperature. These hormones influence how quickly our cells burn energy. When it's cold, the thyroid releases more T4 and T3. These hormones increase the metabolic rate of cells. Think of it like turning up a furnace. Cells burn fuel faster, generating more heat. This increase in metabolic activity helps compensate for heat loss in cold environments. The thyroid gland is sensitive to temperature changes. When it senses a drop in temperature, it releases more T4 and T3 to increase heat production. This feedback loop ensures our bodies adapt to varying temperatures, maintaining a stable internal environment. For temperature regulation, the nervous system activates heat-generating mechanisms. One way is through activating brown fat. Brown fat is in areas like the neck, shoulders, and around vital organs. Brown fat cells have mitochondria, converting energy into heat. When the body senses cold, the sympathetic nervous system activates. It sends signals to brown fat cells to burn calories and generate heat. This process, non-shivering thermogenesis, warms up the body without muscle activity. But what about shivering? That's the nervous system too. When core temperature drops, the hypothalamus sends signals to muscles. These muscle contractions, or shivering, generate heat, raising body temperature. When the temperature rises, our bodies cool down to maintain a safe internal temperature. We have strategies to dissipate excess heat, keeping us comfortable in hot conditions. One primary way our bodies lose heat is through our skin. Our skin acts like a radiator, releasing heat into the environment. When our temperature rises, blood vessels near the skin's surface dilate, allowing more blood flow. This brings heat from the body's core to the surface, where it dissipates into the air. Another way our bodies lose heat is through sweating. Sweat glands release moisture onto the skin's surface. As this moisture evaporates, it takes heat with it, cooling the skin and blood beneath it. It's like our body's air conditioning system, providing a refreshing breeze. These mechanisms prevent overheating, especially during activity or in hot environments. By regulating blood flow and sweat production, our bodies effectively dissipate excess heat, maintaining a safe temperature. Our bodies constantly exchange heat with the environment. This occurs through several mechanisms, regulating our internal temperature. One mechanism is radiation, transferring heat through electromagnetic waves. Think of the sun warming your skin. That's radiation. Our bodies radiate heat, especially when it's cooler outside. This is why we feel colder on a clear night. Clouds absorb some of the heat we radiate. Another mechanism is convection, transferring heat through moving fluids like air or water. Air flowing over our skin carries away heat, cooling us. A gentle breeze on a hot day enhances convective heat loss. Finally, we have evaporation, especially during a workout. When we sweat, moisture on the skin's surface evaporates. As sweat evaporates, it takes heat with it, cooling the skin. Evaporation is highly effective, especially in hot and humid environments.